Hello friends, I am Muhammad Azhar Iqbal Nawargun, Assistant Professor, Department of Physics, Government First Grade College, Mandargi. Today we are going to discuss about network theorems. Before starting the network theorems, first we have to see some basic definitions in electronics. First one, circuit. What do you mean by circuit? A conducting part through which electric current flows are intended to flow from one point to another. It may include various electrical components is called circuit. Second one, parameter. The various elements of the electric circuit like resistance, inductance, capacitor, etc. are called parameters of a circuit. Third definition, linear circuit. If the parameters of a circuit are not changing with the current or voltage, then the circuit is called linear circuit. It means that when you are going to vary the current or voltage in the circuit, the parameters does not change. That type of circuit is called the linear circuit. Fourth one, non-linear circuit. If the parameters of a circuit are changing with the current or voltage, then the circuit is called non-linear circuit. It means that when you are going to change the current or voltage, the parameters also changes. That type of circuit is called non-linear circuit. Fifth one, bilateral circuit. A bilateral circuit is one whose characteristics are same in either direction. It means that when you change the direction of operation, the characteristics does not change. That type of circuit is called bilateral circuit. Sixth one, unilateral circuit. A unilateral circuit is one whose characteristics or properties changes with the direction of its operation. Seventh one, network. A combination of various elements or parameters connected in any manner is called an electric network. Eighth one, passive network. Any network without the source of EMF is called passive network. The network contains only resistors, capacitors, and inductors. It means that a circuit which doesn't have any power supply. It contains only resistors, capacitors, and inductors. That type of network is called passive network. Ninth one, active network. Any network containing source of EMF with the resistors, capacitors, and inductors is called active network. It means that the network contains the power supply as well as the resistors, capacitors, and inductors. That type of network is called as the active network. 10th one, branch. A group of elements in series and having two terminals is called a branch of the circuit, which lies between two junctions. For example, resistance, capacitor, inductor, voltage source, current source are independently in the circuit are called as the branch. 11th one, node or junction. A point in an electrical network having two or more elements or electrical connections is called a node or junction. 12th one, loop. In any electrical network, a closed path formed by the branches is called a loop. 13th one, mesh. A closed path in the circuit which does not enclose any other closed path inside it is called mesh. In the given circuit diagram, two loops are called as mesh. Now we'll see that in the given circuit diagram, there are 5 branches. 1 to 2 is the one branch, 2 to 3 is the second branch, 3 to 4 is the third branch, 2 to 5 is the fourth branch, 1 to 6 is the fifth branch. There are 4 nodes in the circuit. 1, 2, 3 and 5 are the nodes or junctions of the circuit. There are 3 loops in the given circuit. The first loop is 1, 2, 5, 6, 1 is the first loop. 2, 3, 4, 5, 2 is the second loop. 1, 3, 4, 6, 1 is the third loop. In this given circuit, there are only 2 meshes. The first mesh is 1, 2, 5, 6, 1 is the first mesh. 2, 3, 4, 5, 2 is the second mesh. 1, 3, 4, 6, 1 is not a mesh because it contains another closed path. Now we shall move to Kirchhoff's laws. First one, Kirchhoff's current law, KCL. Kirchhoff's current law states that the algebraic sum of currents meeting at a point is always 0. That is, summation I is equal to 0. In the given figure, I1 is moving towards the point, I2 is also moving towards the point, and I3 is moving away from the point, and I4 is also moving away from the point, and I5 is moving inside the point. Now we can write this as I1 plus I2 minus of I3 minus of I4 plus I5 is equal to 0. Here we have taken that, or we considered that the current which is moving towards the point is taken as positive and the current which is moving away from the point is taken as negative. Now this equation can also be written as I1 plus I2 plus I5 is equal to I3 plus I4. That is, incoming current is equal to outgoing current. Second one, Kirchhoff's voltage law, KVL. Kirchhoff's voltage law states that the algebraic sum of the products of current and resistances in each branch of the mesh plus algebraic sum of the EMFs in that path is 0. That is, summation IR plus summation E is equal to 0 for a mesh of electrical network. Now, in electronics, we have to consider some sign conventions regarding EMF and IR drops. EMF. The rise of the potential is taken as positive. The fall of the potential is taken as negative. That is, the rise of the voltage or potential is taken as positive. The fall or decrease in the voltage is taken as negative. Obviously, if we go from negative terminal of a battery to positive terminal of a battery, the EMF is taken as positive. If we go from positive terminal of a battery to negative terminal of a battery, the EMF is taken as negative. IR drops. If we go in the direction of current in a mesh, then IR is taken as negative. And opposite to the direction of current, IR is taken as positive. It means that if we are moving in the direction of the current, the IR should be taken as negative. If we are moving opposite to the direction of the flow of current, the IR product is taken as positive. Now, a circuit has been given to you. Apply Kirchhoff's voltage law to the mesh A, B, C, D and A. A, B, C, D, A. Here, I1 R1 is negative because we are moving in the same direction as current is moving. I2 R2 is also negative. It is also in the same direction as the current is moving. And even is taken as positive because we are moving from negative terminal of a battery to the positive terminal of a battery. I3 R3 is also taken as negative because it is also moving in the direction of the flow of current. I4 R4 is taken as positive because we are moving in the opposite to the direction of flow of current. And E2 is taken as negative because we are moving from the positive terminal of a battery to the negative terminal of a battery. Now these equations can be written as minus of I1 R1 minus of I2 R2 minus of I3 R3 plus I4 R4 plus E1 minus of E2 is equal to 0. Now voltage source. A device that produces voltage output continuously is known as a voltage source. It means that the device which gives a continuous voltage at the output is called voltage source. There are two types of voltage sources: direct voltage source and second one, alternating voltage source. First one, direct voltage source. A device which produces direct voltage output continuously is called a direct voltage source. The examples of the direct voltage source are cell and DC generator. An important characteristic of a direct voltage source is that it maintains the same polarity of the output voltage, that is positive and negative terminals remains the same. When the load resistance RL is connected across such a source, current flows from positive terminal to negative terminal via the load resistance. This is called direct current because it has one direction. The opposite to load current inside the DC source is known as internal resistance. It is denoted by Ri. The simple circuit of the direct voltage source is as shown in this circuit diagram. It contains a battery Eg and the internal resistance of the EMF is Ri. The current I is moving in the circuit and the load resistance RL. That is, the equivalent circuit is internal resistance and the battery. The load current I is equal to Eg divided by RL plus Ri. Terminal voltage V is equal to Eg minus IRI or I into RL. Second one, alternating voltage source. A device which produces alternating voltage output continuously is known as alternating voltage source. Examples are AC mains and AC generators. An important characteristic of alternating voltage source is that it periodically reverses the polarity of the output voltage. When load impedance ZL is connected across such a source, current flows through the circuit that periodically reverses in direction. This is called alternating current. The simple circuit is as shown in the circuit diagram. A alternating power supply, internal resistance of that power supply, current I, and the load resistance impedance ZL. Load current I RMS is equal to Eg divided by ZL plus Zi. Terminal voltage V is equal to Eg minus of IZI or IZL. Constant voltage source. A voltage source which has very low internal impedance as compared with external load impedance is known as a constant voltage source. It means that the internal resistance of the EMF is very low compared with the load resistance. That type of source is called as the constant voltage source. The simple circuit is as shown in the figure. If you plot the graph of output voltage against the load current, the voltage remains constant as the load current varies. Constant current source. A voltage source that has a very high internal impedance compared with external load impedance is considered as a constant current source. It means that the internal resistance of the device or the source is very high compared with the external load resistance. That type of source is called as the constant current source. The simple circuit is as shown in the figure. If we plot the graph of output voltage against the load current, the current remains constant for various values of the output voltage. Recap. Now in this section, you have studied or seen the definitions, basic definitions like circuit, network, branch, node or junction, loop, mesh, etc. You have studied Kirchhoff's current law, Kirchhoff's voltage law, sign conventions, voltage sources, current sources. Now, we will ask some questions on the sessions which I have already covered. Question number 1. A passive network is one which contains, the options are A. Only variable resistance, B. Only two sources of EMF in it, C. Only one source of EMF in it, D. No source of EMF in it. The correct answer is no source of EMF in it because the passive network contains only resistor, capacitor and inductors. Question number 2. A network which contains one or more than one source of EMF is known as, the options are A. Linear network, B. Non-linear network, C. Active network, D. Passive network. The correct answer is active network. Question number 3. A closed path made by several branches of the network is known as, options are A. Branch, B. Loop, C. Circuit, D. Junction. The correct answer is loop. Question number 4. Kirchhoff's current law states that, the options are A. Algebraic sum of currents meeting at a junction is 0. B. Net current flows at the junction is positive. C. No current can leave the junction without some current entering it. The option D. Total sum of the currents meeting at the junction is 0. The correct answer is algebraic sum of currents meeting at a junction is 0. Question number 5. According to Kirchhoff's voltage law, the algebraic sum of all IR drops and EMF in any closed loop of a network is always, the options are A. 0, B. Negative, C. Positive, D. Determined by battery EMF. The correct answer is 0. Question number 6. Kirchhoff's current law is applicable only to, the options are A. Junction in a network, B. Closed loop in a network, C. Electric circuit, D. Electronic circuit. The correct answer is junction in a network. Question number 7. Kirchhoff's voltage law is related to, the options are A. Junction current, B. Battery EMF, C. IR drops, D. Both B and C. The correct answer is both B and C. The references are the books which I have referred is Fundamental of Physics by Halliday, Resnick, Walker, 2002 edition. Principles of Electronics by V.K. Mehta, Rohit. Thank you.